the E1 reaction or unimolecular elimination reaction. You might notice that if you watch the SM1 video that this substrate, as well as what we're reacting it with, is identical to what you saw for the SM1 reaction. So the reaction conditions are really similar, and the E1 elimination is the elimination reaction pathway that competes with the SN1 pathway. And so the substrate preferences are the same, as well as using a weak base. And the difference we can see is that if you heat it up, it'll push this competing reaction towards the elimination rather than the substitution pathway. So we'll say that higher temperatures will favor this E1 reaction occurring over the SM1 pathway. And so let's take a look at the mechanism. The unimolecular here stands for the same thing it did with SM1, and that's that there's only one molecule involved in the rate determining step. And the rate determining step is exactly the same as it was for an SM1. And that is that your substrate by itself has to ionize. So you need to lose the leaving group. And this is a slow step. We're going from something relatively stable to a high energy intermediate, which is a carbocation. So we formed a carbocation as well as the chloride ion. Okay, and so if this was a substitution reaction, right, we'd be saying that a nucleophile would be attacking that positively charged carbon atom. And the nucleophile that would do that wouldn't be this chloride. If you're in solution of water, you'd have a ton of water around, and the water would be attacking that carbon, acting as a nucleophile. If you're going to have an elimination reaction instead, it means that this species that has electrons is acting as a base rather than a nucleophile. So when we say that, we mean it's reacting with a hydrogen nucleus rather than something like a carbon nucleus. And so what would happen in this step would be one of the hydrogens on these beta carbons, and these are all CH3 groups, so they're all identical. So I'm going to draw out just one of the hydrogens, and we could see our base, which is water. So instead of this water attacking there to form an alcohol, it's going to react with a hydrogen, and then the electrons from the hydrogen-carbon bond are going to come in to form the pi bond to form an alkene. Okay, and this was a relatively simple example where we didn't have to consider where we would form the alkene. If these groups are different, you might need to think about that. And with an E1 reaction where it's two steps, there's not the same constraints that we will see for an E2 in terms of where the hydrogen needs to be. It can be any beta hydrogen. And with an E1 elimination, you tend to form the most stable alkene that can possibly form. So forms the most stable possible alkene. And so in terms of alkene stability, the things that you would want to think about would be substitution of the alkene, or possibly conjugation if you had another pi bond, say an allylic or a benzylic system. Okay, the rate law for an E1 reaction, the rate determining step is exactly the same as an SM1, so it has the exact same rate law. So the rate is equal to a rate constant, K, times the concentration of the alkyl halide, and that's it. That's all that's involved. The substrate for an E1 needs to be something that can form a stable carbocation. So you need to be able to form a stable carbocation. And so that's going to be something like a tertiary alkyl halide or an allylic or benzylic alkyl halide. Okay. The base for this reaction must be a weak base. If you have a strong base, it must be a very weak base, I should say. So we'll say very weak base. If you have a reagent that is a strong base under these conditions, that will undergo the E2 pathway. And so E1 eliminations are actually really rare. So you would only see it with something that forms a stable carbocation, a really, really weak base, so things like water or an alcohol, and you'd see this pathway favored over the SM1 at higher temperatures. And in terms of the solvent, you still have that ionization as your slow step, and so you would still prefer to have in terms of the rate, a polar protic solvent would enhance the rate of this reaction. And so E1 reactions, you're not going to see too many of them with alkyl halides. The key example of an E1 reaction that you will see will be in the next chapter, and that's when you have an alcohol and you're dehydrating it, removing water under acidic conditions. So this is neutral. You'll see that under acidic conditions. You will not see an E1 reaction under basic conditions. Under basic conditions, you will see the bimolecular, the E2 reaction.